drive us to work. And what is the foods, or what is the amount of electricity which is used by induction cooker to cook? So anything around us is working, and how is it working, how much electricity is used by it, and how much work will be done can be calculated by using the quantitative aspects of electrolysis. Electrolysis क्या है? It is a non-spontaneous chemical reaction. Means a reaction which cannot occur by its own. In order to carry out such a reaction, we have to be provide the electric current in it, or electricity will pass through it in its molten state or its aqueous state, then the reaction will occur. Here we can see the quantitative aspects, means how we can calculate the mass of जो substance है deposited at the electrode. How much mass will deposited at the electrode when the electricity will pass through an electrolyte in order to carry out a non-spontaneous reaction. So let's see the यहाँ पे we are seeing the quantitative aspects. So that is the quantitative aspects of the quantitative aspects. इसके aspects देखने, aspects of electrolysis. And here we will discuss about the law of Faraday's. Faraday law we will discuss. So there are two laws of Faraday. First law is stating that how much amount, how much substance will deposit on the electrode is directly proportional to the amount of electricity passed through the molten state of electrolyte. So यहाँ पे हम लोग क्या देखेंगे क्वांटिटेटिव एस्पेक्ट ऑफ इलेक्ट्रोलिसिस में कि कितना मास किसी भी सब्सटेंस का इलेक्ट्रोड पे डिपॉजिट होता है, वो डिपेंड करता है कि कितनी इलेक्ट्रिसिटी जो है वो मोल्टेड स्टेट या एक्वस स्टेट ऑफ इलेक्ट्रोलाइट से पास की गई है. सो देयर आर टू लॉज. फैराडे फर्स्ट लॉ. Faraday's first law states, Faraday's first law, what it said that the amount of substance deposit or deposited at an electrode is directly proportional to the amount of electricity passed through an electrolyte. कितनी इलेक्ट्रोलाइट से इलेक्ट्रिसिटी पास की गई है वो बताएगी कितना मास जो है वो इलेक्ट्रोड पे सब्सटेंस का या एलिमेंट का डिपॉजिट होगा. सो केमिकली हाउ वी विल रिप्रेजेंट दैट. अगर हम W को मास से रिप्रेजेंट करते हैं, it is directly proportional to the Q, that is the electricity in coulombs. Here W is the mass of element and Q is the electricity in coulombs. So how much electricity will be passed, that will tell you that कितना जो है वो एलिमेंट का मास जो है वो इलेक्ट्रोड में डिपॉजिट होगा. अगर ये जो प्रोपोर्शनैलिटी साइन है we will remove with the Z, that is ये Z क्या है, that is the electrochemical equivalent. This is the constant electrochemical equivalent and charge will be there and now equal sign will come and W will be there. जो हमारा Q है, then Q is equal to the current passed for the कितने समय के लिए पास हुआ है, Q equal to the product of current into the time for which it passed. So Q here equal to I into T. I is the current in ampere. I क्या है? I is the current in ampere, and what is the T? T is the time in seconds, and time क्या है? Time किसमें है? Seconds में है. So here we can just replace the Q with this. So what we are getting? How much mass of element will be deposited at the electrode is equal to electrochemical equivalent into I into T. So here is the relation according to the first law of Faraday. First law, it states that the amount of an element deposit at electrode is directly proportional to how much electricity will be passed through the molten or aqueous electrolyte. So chemically we represent this. And now what is the W यहाँ पे, that is अगर हमारा W जो है it will be equal to electrochemical equivalent. हमारा जो मास है वो electrochemical equivalent के बराबर हो जाएगा if 1 ampere current is passed for 1 second. So यहाँ पे हम लोग electrochemical equivalent जिसे कि हमने कैपिटल Z के साथ रिप्रेजेंट किया है, equivalent equal to the mass of the element. किसके बराबर हो जाएगा? mass of the element deposited, कहाँ पे डिपॉजिट हो रहा है? deposited at the electrode, at an electrode इसके बराबर हो जाएगा when क्या है? I equal to 1 ampere, करंट कितना होगा? 1 ampere, and T equal to 1 second. So how we will define the electrochemical equivalent? Electrochemical equivalent is the amount of the element which is deposited at an electrode when a current is 1 ampere and it flows only for the 1 second. So